Tutorial 1. Introduction. Video clips will help you to learn how to use the HVAC software toolkit for design of commercial and public buildings. The design process will be illustrated on a sample building. General Services building is a one-story facility of 20,000 square feet of floor area with offices, kitchen area and maintenance shops. To start the design, you will need to study the architectural floor plan drawings, arrangement and size of windows, wall and roof of the building envelope, the occupancy, lighting type and other sources of heat for each building space, space geometry, length of exterior walls, number of windows etc. The space schedule at the upper part of the drawing specifies the occupancy type, floor area and equipment heat gain rates for each space in the building. For example, the schedule shows that assembling room 101 has the floor area of 1575 square feet, is designed for 10 occupants, and houses equipment with a heat gain rate of 4,000 British thermal units per hour. Let's study the room geometry. But first, use the drawing compass shown in the title to learn orientation of the building elevations. The legend shows that the elevations facing left side of the drawing face north. Accordingly, the assembling room with the ID 101 has 4 north-facing windows, 3 east-facing windows. The exterior perimeter of the room includes 44 feet of northern wall and 39 feet of eastern wall. Similar measurements have to be done for all other spaces. The other schedule in the drawing outlines the exterior wall, roof, window and entrance door arrangements. Example, the exterior wall includes 5 layers, a 4-inch brick, an air space, a 1/2-inch fiberboard sheathing, a 3.5-inch batt insulation, and a 1/2-inch gypsum board. This information will be required for the calculation of heat transmission through the exposures. This schematic represents a general air conditioning concept of the building that is usually prepared at early stages of HVAC design by the project engineer. The concept determines general arrangement and interaction of the HVAC equipment and sets forth the HVAC design scope. A central air handling unit shown in the dashed rectangular shell supply a constant volume of conditioned air to the occupied spaces via ductwork. Unit shall include mixing outdoor and return air dampers to provide the building with fresh air, heating coil, cooling coil, and an electric humidifier to maintain the conditions of supply airflow at point A with the temperature and humidity preset sufficiently low to assimilate the heat and moisture from the building throughout the year. In order to provide individual space temperature control, the terminal hot water reheat coils located on the duct runoffs to each space shall increase the supply air temperature maintained by the air handling unit during part space cooling load conditions. Perimeter hot water baseboards shall be located along exterior walls to compensate for the heat losses through building envelope in winter. The reheat coil and baseboard shall be controlled by space thermostat. Air diffusers, not shown in the schematic, shall distribute the air throughout the spaces from the ceiling level. A hot water boiler shall deliver hot water to the baseboards. Reheat coils and the heating coil of air handling unit. A hot water boiler shall deliver hot water to the baseboards. Reheat coils and the heating coil of air handling unit. Coil shall receive chilled water from an air-cooled chiller. The design process consists of a set of streamlined computational and drawing procedures. The software toolkit will perform virtually all the computations. The toolkit encompasses the following main spreadsheets. Design loads will calculate for you the heating and cooling loads, and the supply and ventilation air requirements of the building at hand. Airflow will assist you in sizing the space air diffusers and ductwork. Water flow will size the hot water piping. The spreadsheets linked together form a customized computing system minimizing the design effort and human error margin. After the sample building design is complete, the original architectural floor plan will contain the HVAC equipment, ductwork, and hot water piping layouts drafted based on the calculations performed by the toolkit. To learn the first design step, computing the building thermal loads, Please run the next tutorial.